All right, good afternoon, everyone. Welcome back. Our next segment in the workshop is a panel discussion. And we have 4 panelists. I have prepared a set of questions to get us started. I will ask any of the panelists to go first, and then we can have an open discussion on the remainder of those questions. And after that, will ask for volunteers to ask additional questions from the audience if you have any. Okay. Aside from that, I hope to keep it fairly informal. So while we're having a discussion and you have other questions coming up, feel free to ask and don't have to wait until the end of the day of the session. Okay. In terms of the panelists, we have Richard, who just spoke before. We have Mike Watson, who will speak tomorrow. Mike currently is the VP of AI at Coupa Software. Before that, he was co-founder and CEO of OPEX Analytics. I think a variety of our students worked at that company also. And Mike is also an adjunct professor at my institution, Northwestern University, where he teaches a class on operations management and one on optimization. And he's the lead author of the books Managerial Analytics and Supply Chain Network Design. And he also holds the PhD from Northwestern in IEMS. Next to Mike, we have Barry, who spoke this morning. We all remember that. And then we have Swati Gupta. And Swati Gupta, I know from Georgia Tech. Let me also do the formal introduction. Swati Gupta is an assistant professor and the Fouts Family Early Career Professor at the Milton Stewart School of ISE, which is Industrial and System Engineering at Georgia Tech, the Georgia Institute of Technology. She is the lead of Ethical AI at the NSF AI Institute. She received her PhD in OR from MIT and in 2017, and also a joint bachelor's and master's in computer science from the famous IIT in Delhi. Dr. Gupta's research interests are in optimization, machine learning, and algorithmic fairness. She was also awarded the prestigious Simons Berkeley Research Fellowship, where she was selected as the Microsoft Research Fellow in 2018. She received the Google Women in Engineering Award in India, and her research is partially funded by the NSF and DARPA. Okay, ladies and gentlemen. First question. So there is a lot of discussion in the machine learning community about interpretability. That already has come up a little bit in 2 presentations. Question to the panel. How important is this to practitioners? Are practitioners generally willing to trust machine learning black boxes? And will their trust in black boxes increase or decrease over time as machine learning becomes more ubiquitous? Who would like to start with an opinion on that?
I'll kick it off then.
All right.
All right. I think what I've seen is it depends a lot. So I think when people talk about interpretability, I think someone mentioned it earlier in the talk. I feel like it's when models go bad or when you have a result that you can't explain is when people ask. If the result comes out pretty intuitive, I find that people kind of trust the algorithms. And I think we went through this with optimization. As we were talking about it this morning, I thought like when an optimization or OR model goes wrong, it's like, well, let's look at the data and sort of figure out, I mistyped the decimal point and I changed that and I get an answer that looks more reasonable. And it's just a lot harder to do with a deep learning algorithm or some machine learning algorithm. So you don't see quite as much as that. And I've seen other cases where, if we're doing simple things and people can sort of understand the answer, it's like they don't even ask what algorithm it is. They just sort of trust that this little magic black box sort of works.
So I thought the discussion with combinatorial or integer programming was kind of interesting. Have you seen that also in the past? I was kind of surprised to hear that people don't seem to question the outcomes of running, say, an IP or any linear program. Have you seen that also in practice, Mike?
In practice, I've definitely seen people question the results. Like when I show the result of a linear program or integer programming that doesn't make sense, people sort of ask questions like, why is this? And I found if you can explain why this answer came up, sort of show a couple data points or some samples, that people tend to believe it, but I don't think it's not universally accepted, especially if people don't like what it shows you.
Richard.
I think we have to, one important point is, and I find this extremely interesting and also extremely important, I think one important point is to distinguish interpretability in the sense of, do they understand what the model does? Or can we explain the outcomes? And I believe that's potentially more or less explainability, or a post hoc explainability of a black box model. And I think we will not make these models interpretable, so understandable in themselves, because then we have to make them so simple that we lose their value. I mean, then we only do linear regression with 2 variables, because that's sufficiently complex for most people in day-to-day life. Yeah. But I think there is a value in explainability to create trust, to create acceptance. I think that is important. If we, for example, with our models are able to say, look, we're ordering 30% more than the baseline average because it's this weekday and the weather is nice and there is a football match going on or whatever. Yeah, I think then that creates a lot of trust. And I also feel there is another point to it, why we need explainability and or maybe even interpretability. Because the more we automate, the more we will need experts to fix our models later on, right? The machine learning models are imperfect, so they will make mistakes. There will be disruptive events. I mean, COVID is obviously the example where we have such a strong pattern disruption that our models struggle a lot with that. So we will need someone to understand the outcome of the model. And there again, we need explainability, because else we will just have people sitting there who have no clue why the model is doing something, and then they'll just do whatever they like. Yeah, and I think that's another important point, to enable people to work with these models even if things go wrong. Yeah, and for that we need explainability and an understanding of why certain things are happening. Yeah.
Thank you. Barry.
So I first would want to build off, Richard's point, and I think some of that is that, we can't. Any model, right, has to make assumptions. We also don't have all the data, and we heard that from our second speaker today. In sort of the last mile world that I live in, there's been some famous examples recently of Amazon's algorithms kind of having people walk across 4-lane highways, right? And so that just didn't get captured into their map data or something like that, right? And so that becomes a problem. And but at the same time, I encountered something very similar working for UPS in the early 2000s, and that was that the solutions that came out of our algorithms, in that case, we were just solving routing, IPs. They were just different than people had ever seen, and so it's partly a change management problem, right? And so it's just different. And then, now 20 years later, just had a chance to have the same manager that I had at UPS gave a talk to us at Tippy. And now the algorithms that at UPS, they are giving sort of decision support stop by stop to the drivers, and they typically follow it. And that's then that change management. But it's also, the $1 billion that like UPS in that case put into their IT infrastructure, that, they actually have the best maps in the world. So they know, right, that when I come up to a driveway, that it's still 500 feet to the house and things like that. And so it's kind of, they brought both those things together in that case that have allowed them, to get more effective adoption of the algorithms and the outcomes.
Wonderful.
And I would just like to add to the points that the panel has already made in terms of thinking about interpretability or explainability or transparency of the methods, not just for the management of a company to actually deploy those methods, but also for people who are interacting with those methods. For instance, the last mile drivers or people who are receiving deliveries. Why is my neighborhood the one that gets the deliveries the last? Why do I always have missed deliveries? Whereas if you live a block from me, people get deliveries on time. And making even stakeholders at different levels sort of aware that this is not nefarious behavior on the part of the company, but it's basically maybe a result of an algorithm or a result that can be fixed, or just trying to be more explainable to that and sort of have mechanisms built in that can take that feedback and make decisions maybe overall more equitable is getting more important these days with rising awareness and rising social media and rising exchange of information. The other thing I wanted to make was even though a lot of companies are using models like deep learning, like Richard just mentioned in his talk, I think still trying to achieve an explainable model that can maybe approximate the solutions that your deep net has made is important for auditing purposes. That, maybe we cannot say why your deep net is taking this decision, but maybe we can give you a decision diagram that approximates the decisions and can give you some sense of reliability in the system. And that's getting more and more important with rising cases that are inexplainable. And the third thing I wanted to say was often practitioners come in with their own experience and understanding of the domain, and incorporating that in the models that we have is also perhaps an important piece of the puzzle, because they don't want to trust systems that don't incorporate the knowledge that they've built in over the last 20 years. And so I remember this CTO of a company who was super passionate about inventory routing in the Boston area. He had drawn maps with his hands. He got in different neighborhoods, and he really wanted us to use those neighborhoods to do the inventory routing. And so it's, I think, being transparent or interpretable from there. Okay, this is how we're going to take your data. So, and this is how we're going to run optimization with it is also important. So I guess all different layers of making a system, we need different kinds of interpretability, explainability, transparency.
May I add on? Are you sure, just to be a little bit provocative, are you sure that managers really want to know this? So I'm from Germany. I'm like, there is more SAP than in even other countries, right? I mean, it's big anyways. Now they're all switching to the new platform, to S/4HANA. I don't believe that most managers understand what is really going on in that system, right? And they still do it, right? And they've been running it for a long time, and it's a complete mystery, but somehow it gained some reputation, and because it's SAP, it should be working, but I don't believe anyone really knows what's going on in that system. Yeah, I mean, they're completely output-oriented. Does it work? Do we have big pains or not? Is the performance better? But do you think someone is really asking what's in the inside, what's in the black box, what's the mechanisms?
So I think we are talking about maybe different level of detail. When you talk about what are the different stress points in a system, to me, that's also making the system a little bit more interpretable. That, these were the different stress points, or these were the pain points, and this is the bottleneck. And that's a part of making things more interpretable.
Okay.
What do you say?
I'd also say that people are acculturated to SAP already, right? So even though they're changing systems and it may be different and they don't even understand this, it's been 10 years, and so they're acculturated to that, and so you don't have the change management. If you have something that's interpretable, it is easier to do the change management on the front end, I think.
Yeah, I agree. So they got used to the pain.
Yeah, they got used to it.
Wonderful. Various dimensions, and actually, Swati, I think you make a good transition to the next question. But from Richard, what I'm hearing also, SAP, I don't know whether it's fair to say, but SAP seems to be more an internal kind of mechanism, right? Typically for enterprise planning.
Sure.
Whereas I think, Swati, your points bringing up is really related to the next question, which is about fairness and how does the community and how do different people are impacted by it, and oftentimes the consumer end rather than internal to the company. Not always, of course. But anyway, it brings me to the second question, which is there is a lot of discussion about machine learning fairness. And so question to the panelists, how much is fairness on practitioners' radar? And here specifically when it comes to supply chain decisions. And perhaps there's a difference whether you're thinking about managing your suppliers upstream versus managing downstream with your consumers or your customers. Is it something that companies strive for? And if so, why? Perhaps because it's the right thing to do, or because they worry about negative public relations impact if things go wrong, or maybe there's other reasons. So, question about machine learning fairness in supply chain decisions. I see tentative willingness to jump. All right.
So, I mean, I think, from a algorithmic bias, which is what I think I encounter the most in the kind of work that I do, right? There's actually been a really large literature looking at this in the context of, workers, particularly in a gig economy, right? And that, if you're a driver for Uber or Grubhub, right, you're going to make money per ride or per delivery that you do. So you want algorithms that are going to give you, right, at least equal work to every other, driver, given, certain constraints. Or even similarly, right, if you're, or in general, in terms of, the distribution of workload, right? People want to be treated, at least equally over time, in terms of how that workload gets distributed. One person doesn't want to feel like, geez, I'm always doing the 10-hour or 12-hour delivery day. So-and-so, we're making a fixed union wage or something. They end up doing 6 hours, right? I mean, that's not something that's okay. So I think, building in that need into your algorithm, or at least assessing your algorithm's, outcome among the different, the different measures, which I think is something that Jorn was talking about earlier, right? There could be different, even if you're optimizing for profit, you may want to look at that outcome over different measures to see what happens.
Very, very interesting. Now that you say that, it reminds me a little bit, and maybe what is lacking, I haven't heard anything about that, is the game theoretic analysis of these algorithms, right? If I am one of the employees and you route the work to and I'm the fastest because I work hard, I'm going to figure out that by me working hard, you give me more work because I'm more profitable for you, so I'm going to start working less hard. Right? That kind of thing that I always think humans are very smart, and in all these smart algorithms, we hardly ever kind of anticipate that, which is a very different notion of fairness. I think typically fairness it is to make sure that everybody has a certain level of equitable treatment, right?
But I think, Jan, so this strategic behavior somewhat sort of motivates the need for equitable service or equitable access,
yes,
or equitable conditions, because otherwise it creates an incentive for people to stop using a service and go somewhere else where their needs are met better, right? So that sort of gets into the question why organizations are thinking about it, or why they need to think about it more. And a lot of examples that Barry just mentioned, and we've heard of more. For instance, like service related to zip codes. Zip codes correlate with demographic features. They correlate with the spending power of people. And so that creates a disparity in service, that creates a disparity. There have been a lot of articles about Walmart giving groceries to poor regions at a higher price, or Princeton giving education to people at different prices because their costs of shipping a book was different across different zip codes. You see a lot of slack about Uber, the gig economy. As Barry mentioned, Uber drivers with the prices that were hiked in cases of emergency. Amazon is facing lawsuits for hiking up prices during the pandemic. Recently, Chicago actually sued DoorDash and Grubhub for fake information on their websites across different restaurants. And these services these e-commerce services could sort of say that, we were trying to increase the demand for these restaurants. We are trying to keep them in business. But from the perspective of the consumer, there are legal issues at hand, there might be policy issues, and there might be just optics that feed into the profit margins of these companies. And so these concerns are actually getting very important.
Yeah, and I think we're not surprised that there is a trade-off sometimes between profit maximization and fairness, and as Barry said, but the nice thing I thought was the decrease in the profit could be rather small with a strong increase in fairness, right? So kind of that joint consideration. Richard?
Just one question, because I really don't know this topic well, but why would it be more unfair through machine learning? Was it not unfair, equally unfair before? I don't know.
That's
Have
the
we been
next
fair to our suppliers before, or to our customers? I'm not sure
That's
I
an
fully
excellent
understand
question.
that.
No, that's an excellent question. These issues have not been, you know, these are not new issues. They've not just been here for the last 5 years. These have been here since forever. But with machine learning and automated systems, we are just scaling these issues massively. We are getting so much more involvement with people with e-commerce. People have now lost jobs over the pandemic, and so the only source of income is the gig economy. These issues are just now much more widespread than they were before.
Okay.
Well, and I think I'd also say, though, that there was this idea that algorithms are objective, right? And that and as a result, they must be fair. But of course, algorithms and your choice of objective, and then obviously we all know about the training data issues with some of the image recognition stuff, and so they aren't objective because it depends what we put into them in many ways. It depends how we design them, and I think that's part of the issue, is that people had a perception, and that's really not true, and so there's been a bit of a struggle as people try to come to terms with that.
There's a good story I have related to that. I was meeting with someone, like a 3-star general in the military, and talking about algorithms, and he was talking about, he was worried about an algorithm automatically allocating some good, like food or water or ammunition, to some unit, but as soon as you make that allocation, one unit gets this much and another unit gets maybe shorted. And you could tell that he was worried about the algorithm being accurate, but I had the same thought that you did. I'm like, somehow that's just, if you only have a limited amount, somehow that decision had to be made before, but I could sense that he would rather a person have made that decision and say, this is my decision, rather than just trusting an algorithm to make it.
Okay.
That's interesting.
Interesting. Thank you. Next question is a little bit more academic, in the sense of, from your opinion, what are the machine learning breakthroughs you are seeing from the research community that you wish would be used more widely by practitioners? And what are the challenges that give you pause in recommending the implementation of machine learning to practicing supply chain managers, if any?
So I think for the breakthroughs, numerous breakthroughs come to my mind. For instance, just sort of interpreting outcomes of a black box machine learning model, because that sort of leads to our first discussion here. In terms of other breakthroughs, I think from a very sort of algorithmic fairness perspective, understanding the problems that technology or operations research or optimization can actually help us with, and understanding issues that cannot be helped by just making an optimization problem is important. I think this is something that would go into practice, or understanding the fact that in some problems having human in the loop is actually critical to be able to audit continually a machine learning process. In terms of sort of, there's a lot of decisions that go into developing any technology for supply chains, or a general machine learning problem, and trying to understand sort of where in the pipeline you could have an unintended consequence prop up because of the bias in data, or because of the modeling assumptions, or because of the proxies you're using, or because of the groups that you're concerned with, or the data that you're actually not observing on people. I think there are various studies that talk about how do you fix a data bias problem, or how do you fix a problem where you have very small data on minorities, so the image recognition example, where you have a huge data imbalance, or how do you work with different metrics that seem competing and maybe there's a trade-off and you cannot define what fair is. How do you approach that? Or how do you even post-process your your deep learning solutions and post-process them so that they have a semblance of fairness? Or recognizing, this is a management question. At this point, I need a clear management policy, and I don't want to go with the optimization. I think all of this, there's a lot that can be brought to practice from the current advances in algorithmic fairness and machine learning.
So I'll jump in on one point that you made. I thought it was funny. I've learned long ago, like you made a point, like what we wish practitioners knew is like what these problems can and can't solve and what their range is. And I've long learned that people were very interested in machine learning. I was working with lots of clients who wanted to try it out. And I learned that I want to be in the room when they're brainstorming, because I wasn't in the room. I'm going to go talk, and then we'll come back with 3 problems. They come back with some problems, and like, oh, we can solve these problems with like a bar chart. But we need to have something more in depth if you really want to try this to sort of make an impact with machine learning. So I think that was a good one to figure out. Where is the limit? What can and can't you solve, and what are the techniques that you can use?
Yeah, I mean, the reason I also asked this is because I think we have the implicit assumption here that these algorithms will be directly implemented almost in an automatic mode, right? So, and I always feel it's important to distinguish between automation versus kind of decision support. And somehow most of what I think implicitly we're learning here today also is like we're just going to implement it and run it let the machine run it, right? Versus probably in terms of interpretability, etc., you could have a suggestion system, and if you have problems explaining the recommendation, maybe you...
Or detecting the problems.
Or detecting them, yeah.
You can't expect a human to go through 1 million purchases or cases and figure out a pattern. I mean, detecting problems is great, something we can do with with a machine learning algorithm, but understanding why that problem is happening is where probably we need a human input, or we need people from different areas to come in.
Excellent point. Richard.
From my experience, what I see, and we do a lot of work with companies, and I don't even think it's the machine learning part, it's the implementation part and getting out of this prototype phase. Yeah, we do a lot of stuff, and at the end we have a nice prototype. We can show that it works well. We get incredible improvements. But then it somehow dies, yeah, and it gets stuck in the organization. There is change management. We have to change processes. It's about automation. It's about, we're losing expert knowledge, and all kinds of reasons. So I think that's right now, at least for us, what I see is very often the biggest problem. Yeah, not that we have the machine learning solution, not that it's not a technical thing. We could roll it out, but it gets stuck somewhere in the organization. Yeah, and I think this will only really change when the big guys, the big software companies, start actively doing this. I don't know. I'm sure Mike has followed this. If you look at, I don't know if you saw that, Blue Yonder is this company that it's a German company, but I'm not trying to be patriotic, right? But they were kind of very early. They were very early in applying this in retail. Yeah, they were bought by JDA, the number 3 supply chain company. JDA is now called Blue Yonder. Yeah, because they are now really focusing on this, and I think this will drive this. If we have more and more big companies who have packaged solutions and supply really machine learning, and that will, the SAPs, the Oracles, the JDAs, and so on, I think they will be the key drivers to bring that in the organization.
I think I like this because I think it goes to what I've seen at Coupa Software. So we do some pretty basic machine learning where we're cleaning data, like normalizing suppliers to figure, you'd be surprised how many ways you can spell Uber. It's just trying to figure out that's that. And I think some of it's just the discipline of implementing it. It's like, we're a software company. We have people that are dedicated. They've been dedicated for 2 years. They'll be dedicated for 5 more years. They're going to work really hard to worry about all the edge cases to make this really work. And when I've seen this in companies and industry, I don't see that same discipline and same commitment to the problem, and then it can easily start to break down and never get out of the prototype mode. Yeah.
Interesting, but Richard, pushing back a little bit even on the prototyping. So the work that you're in and we've been looking at, I have to admit sometimes I wonder, okay, would I actually now recommend a company to really start using our algorithm? I would be careful, and here's one of the reasons: that of course all of this is under a stationary environment. Right? And none of these, or very few companies, have many of their product lines being very stationary. I really have no idea what would happen if it becomes very seasonal. We could model that, but then the point being, the machine is trained on the assumptions, right? And to what extent are our assumptions really reflective of reality? I'm a little bit more worried about that. Now, I'm not worried if we do this for Netflix or a recommendation engine, what movie should you watch next. The consequence of making the wrong suggestion is very small, right? But for things that impact people's lives more, then I'm a little bit more, perhaps.
Recommending jobs.
Yeah.
Right.
But that's just
okay. I have a thought though. I thought about this in a little bit different way, and that was sort of where, what are some of the big problems that we're facing in supply chains? And I think there's two really big ones right now, and it's sort of the supply chain resiliency, and there's sort of the problems brought on by the Great Resignation, right? And I think there is we've talked about some of the pitfalls, but some of the promise would be that we have some machine learning tools that could be really powerful in helping to increase supply chain resiliency. And I was, in fact, turned to kind of the work of my colleagues. And so I have some colleagues, Kong Zhao and Jen Blackhurst right now, who are looking at what, using graph neural nets to do prediction within supply chains, looking at, those relationships with suppliers, using that graph neural net to then build the prediction, and you can start predicting kind of where failures may occur, right? And then hopefully you get ahead of that and you're able to shore that up. Or another one of my colleagues has been using kind of this combination of convolution and LSTM neural nets to capture both the spatial and the temporal in data, and he's used them to do accident prediction or kind of event prediction within an urban environment. But you could use those same concepts and apply them to kind of these rare events that would happen, in supply chain failures. And then as we think of the Great Resignation, I mean, one of the obvious outcomes of this, it was already happening, and just like so many other things, it's going to accelerate automation, right? So we've clearly seen automation in a manufacturing standpoint, but I think everybody we talked to said, look, like autonomous, over the road trucking is 15 years away. I don't think so anymore, right? I think they're going to really try to pull that into this decade. So then, the role of machine learning there, clearly machine learning is helping to drive these autonomous vehicles, but you also need sort of the coordination that goes along with it, because now there may not even be human decision makers, or at least not, there's not the driver there. So you need some more, the machine learning that's going to drive the kind of the coordination of these things. So I think there's some pitfalls, but there's some real promise out there that we also should be, I think, looking to. And I think particularly if you're an academic, a scholar, or a researcher, these are great opportunities, right? And trying to get in there and kind of solve, some of these problems and look at these is a great opportunity.
So that relates me to a question, not on my thing, but maybe we can discuss later, is a little bit how to get this stuff published for those who are in academia. All right, last question that I had prepared for more from a practitioner's perspective. Specifically, where has machine learning currently been utilized in supply chain operations, to the extent that you know? And where do you anticipate to see machine learning implemented in the near future? In other words, what works well today, and what are the pain points you are experiencing in practice that you wish would be given more serious attention by researchers?
I think that's you, Mike.
That's a question to a practitioner.
You guys work with industry too, so I think we see it. So I've seen it from the point of view of like consulting and seeing what our clients are using, and we use it. We use it a lot for cleaning data, such as machine learning has been really well for like reading invoices to see if you're getting invoiced correctly from your suppliers, just understanding that stuff at scale. Like there's some examples like it's not worth it for a person to look at invoices for $25 mistakes, but if you can do it at scale, it's worth it. We've used it for root cause problems or fraud detection, so looking for anomalies in data. So we've seen that. I'd also like to point out what I've seen work well in practice with these algorithms is that there tends to be a tendency for people who are trained in machine learning that they want to apply the best and the coolest algorithms possible. And we found the best implementations having a combination of this part of the problem, I can just use these six rules, and that'll really knock this out. And then I need a small machine learning algorithm here, and then maybe another rule there. It's sort of this combination of things, and more of an attitude of, let's roll up our sleeves and actually solve the problem, and not necessarily worry about the coolest algorithm possible to solve this problem.
And Mike, would you say that a heuristic is just fine for a lot of industry practitioners, right? They're not worried about being 1% from optimal. If they can capture a lot of value, is
Exactly. Yeah, exactly. I mean, one good example just came up recently is we were trying to figure out, where there's a lot of discussion like how to automate classification of some data to figure out what this data actually meant. And then we talked about it for like, it must have been going back and forth for a day. We're like, let's just look at the data. And there was like 300 events. We were like, we could have just gone through manually and done all those in the time it took to think about what an algorithm might look like, much less try to implement that. So I think there's some of that practitioners, and I think we're to blame too, because we have all these cool algorithms and we come out and I want to do it too. I'm probably to blame too, because I'm like, yeah, let's do something really cool. And it's like, well, let's just do something to get the problem solved.
Yeah. Any things that so I like your identification, etc. That is still far removed from the topic here, like prescriptive kind of machine learning, right? Where the algorithm will tell you what we should do. Do you see that happening anytime soon, Mike?
Well, I mean, from my perspective, for sure, like, the fraud detection is very prescriptive in the sense of like, this looks like a fraud, go out and take advantage of this, or this looks like a root cause, like go out and figure out what's causing that. So I think the industry really wants those solutions. The industry's primed for it with optimizations. People know that these algorithms can work, and I think people in the industry are very curious to see, can machine learning prescribe what I should do? So there's definitely a ton of interest in industry wanting to put these things in place, to prescribe, to come up with prescriptions.
Sure.
So I think there is quite a big number of applications, commercial applications in really predictive analytics in forecasting, using more data to better forecast. I think there is a whole new generation of software out there. Many of those companies that are working on SNOP type of applications, right, like 09 technology, and that was the former founder of I2 Technologies, which we probably all remember, right? And so I think there is a number of commercial applications out there today that use machine learning methods to do better forecasting. And I think that's the first step, because if you do predictive analytics successfully, I think you will also be building trust to do prescriptive analytics. And what you said before, Jan, I completely agree with you that your algorithm and our reinforcement learning, I think that's 10 years from now or something like this. But we do have algorithms which are more robust, more reliable, right? Maybe not so super fancy, yeah. But I think we have pretty good stuff in the box that can be used, and I see more and more companies actually doing this and providing this. So that's the development I see, and the biggest potential I see for the repetitive stuff, yeah, forecasting, determining inventories, and so on. And I like what Amazon has been doing. They had this big, I don't know if you know this, hands off the wheel project, yeah, where they said, well, we have so much data, we have such powerful algorithms that can do basically the buying process, the forecasting, and also the inventory allocation. Yeah, and they realized that their algorithms got so good, yeah, much better, and that human interventions were actually not making things better but worse. Yeah, so they said, so they had this hands off the wheel project to say, yeah, we don't want human planners to intervene anymore. We just want them to be there if something goes really wrong. Yeah, the fixers. Yeah, something like this. And I find this is interesting. I think there are good examples, but not that many yet.
Yeah. I don't think the Amazon, you can even extend it. I've heard it be like, if something goes wrong, most companies' tendency is like, let's fix the problem, what went wrong. And Amazon has a discipline, at least I think they do, where they say if something goes wrong, let's go back and fix the algorithm so that it doesn't go wrong again. Let's go adjust that. And it's sort of this culture of sort of a mindset of like, okay, we're going to use an algorithm. It is going to fail, just like people are going to fail, but we're going to keep adjusting the algorithm over time.
Wonderful.
So to add to these applications, I wanted to mention some of the sort of cutting edge work that some of my colleagues are involved in with the SF Express, Benoit Montreux and his Physical Internet Lab, trying to predict bottlenecks in a hierarchical network of supply chain for this huge company. And with these predictions, it's a combination of predictions and optimization tools, and that then can start giving you examples of decision processes, such as where should you open a new depot or a hub for increasing flow in the demand or for being more efficient in the system, where could be potential breakpoints in this management. And then I think another important and interesting venue would be how should we price services like same-day delivery for different customers and predicting the cost of such services. I think there's just so much data. I can't think of any single example where there's no data and we can't do machine learning. I think machine learning can help in so many parts of the supply chain combined with an optimization.
What I found has been interesting too is that I think the better companies or the more interesting ones are people are saying, can I solve some problem that I was never able to solve before? And so like, you know, I've been involved in some projects like with railroad companies looking at worker safety. Like, can I use the data that I have to predict when someone may have an accident so I can get out in front of it and prevent these accidents from happening? And so I think those are some interesting cases of machine learning in industry too, is that let's just solve something net new where we probably have some data and let's tackle that.
Very cool. Thank you so much. I would like to open it up for any questions from the audience, both here in person as well as online, although I cannot read anything online, but if anything online comes in, maybe somebody can read it. Are there any questions that you guys would like to hear the panel's opinion on?
I'm curious, in the world we're in, from an academic perspective, are you partnering across disciplines in your research? And if you are, how is that going? And if not, do you see opportunities within your each of your academic settings to do so? I'm just curious.
So I do actually talk a lot with colleagues across different departments. And I guess the furthest to operations research is law and policy. And having these interactions and collaborations has been very interesting over the last 2 years. I've been thinking about hiring and admissions and what are the discrimination laws that come into play. And there is some difference in terminology and there's a difference in thinking. To me, an algorithm can do whatever a human can do. But legally speaking, a human has responsibility of the outcomes, an algorithm does not. So that's been, I guess, that's been a very interesting collaboration. And I think as we are, especially when you're thinking about algorithmic fairness problems or ethical decisions in supply chains, I think these kind of collaborations need to prop up. And there is a huge need for these to understand, what is even something that's ethical or legally allowed in the society.
And I think what we're increasingly seeing is, disciplines that you might consider application oriented. So somebody in a business school, right? People in marketing, they have applications, and then they a good example of one that we just had was that we had a marketing professor that was really interested in kind of the ways in which people are expressing themselves through emoticons, right? Like you're sending texts, and obviously we use people use emojis. I'm not very good at it, but I understand there are people that are, and she wanted to test this, but to do that, right? To do it with hundreds of thousands of messages, you have to automate that process. So she partnered with one of our business analytics faculty who was able to do machine reading of those messages, and actually easier than NLP because they were images, right? And then kind of work on the sentiment that goes along with that. And so we're seeing more and more of that kind of interaction, whether it's within our own college or then particularly into the the health sciences colleges, interest in the value of message boards for smoking cessation programs and support. So if you to analyze that, you need sort of the experts in those and the psychology of smoking cessation, but then you also need the people with the technical background who can write the natural language processing to kind of read and understand what the message boards are saying, because otherwise it's there's just way too much data there for even a team of researchers to go in and analyze. So I think those opportunities, I'd say it's really increased in the last 2 years.
Can I add an answer to that? So, is my mic okay, or should I use? Okay, so iDisk, which is the institute that is hosting this event, has a program called iDisk Fellows, where a iDisk Fellow is a senior ish PhD student who we sort of, so that person can serve as a kind of short-term helper for research projects by faculty members in other departments. So, we've had people in psychology or astronomy or marketing or public policy who need a computational part of their research, often involving machine learning, but not always. And for them or their students to figure out how to do it might take 2 weeks, whereas the iDisk fellow already has done things like that many times and could do it in an afternoon. And that provides, I think, really important interdisciplinary experience for the student, as well as like helping to facilitate the faculty members' research.
Thank you. Next question in the back.
Yeah, actually, there's one question from our online audience. The question is, how do you model the downstream impact of policy solved by the machine learning or reinforcement learning algorithms like fairness?
How do you model?
Yeah, how do you model the downstream impact?
Okay, so so when you think about impact on people of any downstream policies, I think you can think of them as, perhaps that's what I do. I try to look at, is there any impact on service? Is there any impact on access? And is there any impact on different stakeholders that are not a part of my model or not a part of the objectives? And to quantify the impact, there are many examples. What we saw in Barry's talk was maximize the minimum cost on any group or minimize the maximum impact. Of course, when you're working with real data and people, the notion of a group can be very different. And these issues are not new. So in a paper as early as 93, there were 24 different metrics of fairness for a facility location problem. So just the question of how do you quantify impact can be dependent on the application. It can be dependent on how that data was collected, what is the process there, and that needs some unpacking. So that's a very long answer, which is not informative, I guess.
Good.
So multiple metrics that one can think about and maybe even think about, can I get a solution that's relatively okay across all of these metrics? So think about Pareto optimal solutions or multi-criteria objectives, and how do you form those objectives really depends on the application. That's just a start. There's more layers that come in with the uncertainties in data and policy around that application.
Very good, thank you. Oh, we have another question.
So there has been a lot of discussion with fairness, particularly because machine learning algorithms have been applied in a lot of social settings, like crime prediction, getting credit, getting insurance, getting a job, who gets assigned a specific job in a company, or a lot of issues that arise. The question of fairness and how to be fair. What is the role of technical people who are actually coding these algorithms? What are our responsibility, or is it just the responsibility of the managers and the people who are actually overseeing what goes on? What is our responsibility? And also not just in machine learning, but it also in supply chain and optimization. What is our responsibility in that situation where these solutions that we are producing are being applied? Where do we see ourselves fitting in that discussion?
That's an excellent question. Again, answers at various levels. So I think the first responsibility of us as sort of technical people is to ask whether the question that's being asked of technology is that even a relevant question. If you're using court proceedings to predict whether somebody is guilty or not, why not use court proceedings to also figure out whether a judge is biased or not? Who has the power in the system and who is the system being built for? I think that's the first question. Whether it's even the right question to ask, there are many image recognition studies that have a very high accuracy in predicting whether somebody is guilty of a crime, but do we want that kind of technology that can look at a person and predict whether they're going to commit a crime or not? The third thing that comes as technical people is, are we using data that was collected with consent? Are we looking at data that was collected for a different reason? What is a data sheet for a data set? So, that's very nice work by Jamie Morgenstern and her colleagues, trying to think about, is this data even relevant for my application, and do I have consent to use that data? The next thing is really an optimization question. What are the proxies we are using? Do these proxies accurately represent what's happening in my data set or not? And what are the models that I'm building out of it? What is this model actually optimizing for? Is it just the cost? Is it modeling the impact on different groups? What are the different groups that you could have in an application? The next thing is understanding the impact of decisions. My model is taking some decisions. Are these decisions very sensitive to perturbations in the data, to uncertainties? And what are the groups that it can have a different impact on, or even individuals? What is the impact of these decisions? And feedback loops. Can we take information from people and feed it back into our systems? So I think thinking about these different aspects and deciding whether you want to be involved in that technology or not and build that or not.
So I'll give it like a little bit of a different, more generic twist to it too. And I give this advice to sort of technical people in general, especially people who are starting their career, is that as a technical person, there's a tendency that you're just going to focus on the technical problem. And I encourage everyone to get the business context. So this is going to help you in fairness stuff, like understand what data is, what it's telling you, what your output is. But it's also general, outside of fairness, there's good business practice to understand what am I trying to solve. And then I think that can help you, sort of sort through and surface these issues. And I think the best, or some of the good ethical things I've read about, how to build an ethical AI team is you want to make sure that everyone on the team has like a say. And so as you're working on these projects, you want at least, if you see something, and this is where the context matters, if you see something that looks kind of troubling, is just to be able to raise that issue up and then have other people talk about it and discuss it and hopefully come up with something that's reasonable.
But I do think that the technical people have an important role. Like the things that Swati was pointing out, right? Like the technical people are probably the ones that know that there could be something that goes wrong, right? And if you don't raise it, it's not clear that the managers or the others involved will know, right? They're going to default to that. It's an algorithm. It's objective. There can't be anything wrong with it because that's kind of the conventional wisdom, but clearly it's not true. So I do think that technical people, it's really important that we raise the issues because we're now, hopefully aware of it.
And that we translate the issues to communities that are not as technical as well. So a few years back, Europe passed the GDPR laws, that is General Data Protection Regulation, that asks that a data subject, person who's interacting with the technology, can be told why a certain decision was made for them. And there was a huge panic in Europe because policymakers and lawyers didn't know how to ask machine learning algorithms what was happening or how to interpret a deep net. And that's where a technical person can come in and say, these are the meta features, this is what I know about my users, and this is what I've inferred, and maybe there's a bias problem in this mechanism, and to basically audit technology even by unpacking the various levels.
I think it's a good point also that the fact that technical people need to surface this up. I've managed many projects, and it's like I've been so thankful when the technical people on the team do raise these kind of issues. So I think you shouldn't assume that the manager, whoever's running the project, knows about the ins and outs that you're finding. If you find something important, raise it, because this is so important to get the visibility. There's almost no way that everyone's going to know what you know, and if you can surface what you know, that's better.
And I think in our graduate programs, we often talk to people who are in a very niche area of our research expertise, and we interact with them, and we talk at that very depth, right? But it's important to sort of just abstract out what you're doing and communicate with your friends and other disciplines like biology or law, policy, economics, and try to explain what you're doing, because that's a skill that's going to be very important in making sure that your decisions are nice.
Are there any other questions? Oh, you do? So there was a data sheet for data. Thank you very much, first of all, for all the answers that you've given me. You mentioned data sheets for data sets where there's a data sheet that explains what the data set, where it comes from, each feature, and so on. And there has been a lot of discussion with that. Do you see that also? Do you see that kind of thing being applied for optimization models as well? that can be used to make supply chain decisions, for example?
Yes, I think that would be very nice if we could do that for any data set that we use and deploy and models that we develop. I think that would be really nice.
Yeah, so my question is around, or rather a comment, is around the interpretability versus accuracy argument. So, not argument, like if you see supply chain algorithms, they are very theoretical, right? The work we do is pretty theoretical and very interpretable. Whereas the deep learning folks, they are very accurate. But theoretically, we are okay. If we don't have sufficient theory, we are like satisfied because they are accurate to an extent that our traditional models are not able to do it. So I went for an internship and the company gave me a problem. It was a prediction problem and they did not want to use neural networks. So I said, what should we do? And then I kind of made a model which was PCA based. It was interpretable with no theoretical guarantees as such. It really worked well. It beat their existing baseline and we did really well and the company said, good job. But I come back to my university and I show it and they say, well, then what are you going to do with it? So I feel like while accuracy is being rewarded by the ML community, interpretability is rewarded by, full interpretability is rewarded by the academic community. But there is something in between, which is like, we are focusing on interpretable stuff, but we care about accuracy too. And I am currently struggling to put it in a place where it can go through, because I cannot publish in an ML, whatever conference or something. I cannot publish in ORMS. So what should I do? So I'm facing this struggle and I wanted your comments, thoughts, opinions on this. Yeah.
I'm really glad I'm tenured already. Because that is, I think that is a very relevant question. I'm struggling with exactly this as well. I mean, we have this team here, people who are PhD students, postdocs, assistant professors, and our community has been extremely theoretical. You're absolutely right. Trying to get exactness, which is also a little bit strange. We made many assumptions. Yeah, I mean, we're fine with incredible assumptions in terms of distributions and so on, right? Making these assumptions for the purpose of getting some theoretical optimum and proving this. But we've been doing this for 20, 30, 40 years now, and now it gets very difficult if we have these fuzzy machine learning models, right? And we cannot prove anything anymore. And there is just, to some of the models, there are just no theoretical proof. So the question is now, do we go back to something simple and try to prove it, right? Or do we try to make something relevant for companies? As you said, the companies don't care about a theoretical proof of optimality in the limiting case of n to infinity. I mean, it's just, I believe you simply do not care about that, right? I mean, and you don't even care about a theoretical optimum, but you want some improvement. So can we demonstrate that? And I think we're stuck in that in the middle, yeah, and also in terms of research. And I'm a little bit scared that because we're so theoretically focused in proving something, someone else is simply going to do the stuff, yeah? And some, whatever, Oracle or SAP or some other company, yeah, and this happened 20, 30 years ago. The systems we see today, they were not built on our theoretical expertise. Yeah? They got some smart IT people who understood mathematics, they looked at some textbooks, and they implemented something. But that was never state-of-the-art operations management, and it still, in most systems, is not super sophisticated. So the gap between what we have been doing and what industry and practice is doing is huge. Yeah? And I think we have to figure out today, can we reduce that gap? Can we still be rigorous? I still believe we need to be rigorous, yeah, but without creating problems that are not relevant to practice, yeah. And so, sorry, it's a long answer, but this is exactly what I'm struggling with as well. And actually, I didn't give you an answer. I just said I agree with you, right? I mean, I didn't have a good answer. Yeah, but maybe Jan, I mean, you have been very successful in this discipline. Yeah, and Larry, you have thoughts on this. I would really be interested how you deal with this, because I mean, you see that with the paper you did with and you get a lot of headwind. Right?
Yeah. So to put that in perspective, I think we all share that view, the challenge. And, I was talking with Joran about that. The paper, I think Joran started first in 2017, right? We started really working on it in 18. It's been 3 years. It's been, among all my papers, perhaps the longest journey. And, of course, as a co-author, I don't enjoy that process. But then from an editorial perspective, I can, of course, understand it. Because, see, what is the challenge? The challenge is we write those papers, and I think they're very relevant, they're important, they're exciting, and so on and so forth. But the question always remains, from a scholarly perspective, how general is it? How much can I trust this, right? And de facto, it ends up being a numerical study. And that's always been a problem, to get a paper published that is purely a numerical study or a simulation study. That's not to say that it's not important. Sometimes it can be very important, but our community has an issue with that. And I understand where the issue comes from. So the question is a little bit, what are you going to do from here on? And to be honest, I don't know exactly. Right now, I'm in Richard's position. I've got the luxury that I don't need to worry about it. But still, if we put all that work in, I care about my co-authors, I care that their career goes well and that it actually works and that we're not doing it just in vain, right? It's okay to have some working papers that become eternal working papers, but you don't want to have too many of those. So I don't know, and I kind of wonder where the community will go with it. What I do not enjoy much is there's two ways of doing this. There's then saying like, look, I'm going to make a paper and I'm going to massage it such that I can put a theoretical bound in there. And there's a subset of the community that then is very impressed, and then that paper gets published. Even though, if you look at it a bit carefully, that bound is totally useless, right? But nevertheless, certain people like that, and there's a little bit of chicken and an egg type of problem in that. And this kind of research, you start appreciating more once you've gone through it yourself and you know exactly what it all takes. But if somebody has never done it, they look at it from a perspective that is rather different. So I don't know exactly where it's going to go, but I also do know that over time we figure it out. So my suggestion would be you keep on going with it. But I understand that there's a little bit of risk involved. However, as I told Joran, is when we're at the dawn of something new, that's where all the rewards are, right? It is very clear in hindsight that the first paper gets credits way more than whatever else comes afterwards. So if you do something new, novelty is rewarded much more than precision in our business, even though we argue we got to be rigorous, right? But when it comes to evaluation and impact, novelty is 10 times more important than the second paper that refines something. Refinements do not get much value. So it's high risk, high reward. That's what I would say. Maybe Larry, you also give your experience a little bit.
Oh, I mean, I was thinking that it feels a lot like, I mean, sort of like you said, Jan, it feels a lot like what many people in the OR community have gone through for decades, which is, if you're doing work that doesn't involve proving theorems, then it can be hard to publish. And machine learning is a little bit different, but it's similar in the same way. If you're someone who's interested in heuristics, for example, or you're someone who's interested in, building a big optimization model that gets solved with an off-the-shelf solver, and you have no theoretical results, it can be very hard to publish that kind of work unless it's in an applied journal like Inform's Journal on Applied Analytics or something like that. So again, I'm not answering, I'm only agreeing that this is a perennial problem.
But can we not, I believe the machine learning community is not less rigorous, right? I mean, they are rigorous, they're doing good things. Can we not learn from them? I mean, it's not just that they're making up some algorithms and saying, oh, this is the best algorithm, and they cannot prove that claim. So, I mean, they're rigorous researchers. Can we not learn in our community from that community to say, can we not adopt their standards at least, and also agree that they're not doing everything wrong? I mean, they're not fools. Yeah, I mean, they're still serious researchers. Can we not learn from them if we're applying their methods? Yeah, now we're applying their methods, but trying to do what OR research has been doing the last 30 years. Yeah, it doesn't go together.
Richard, maybe one way I also sometimes think about this is there's also a clash between, I'd say, the economics, social science perspective versus the engineering perspective, right? The engineering perspective is we're just going to make something that works. It works better, so it's great. An economist, and I know that because I work with quite a bit of economists in my department, that's not their purpose, right? When they write a model, they know that the model is not reflective of reality, but the point is to get insight and better understanding on the phenomenon at play. And so it's kind of a very different mindset. And I think with ML, you get kind of at the intersection of these two things, right? And it's also the difference between research that is very practical, that is implementable. And now with all the focus on data-driven, that stuff comes up more. If we talk about data-driven, that means it's implementable, it's relevant, and so on, but that's not necessarily in line with promoting more insights. So from a scholarly perspective, it's not because something is data-driven that you understand it better. And then you have to ask yourself from an educational perspective, okay, so are we any better off in terms of understanding? And I think that's kind of perhaps also where the challenge is a little bit. And then I would say maybe there's different journals that focus on different types of insights, right? And if you go to management science, you have this conflict. On the one hand, there's science and there's management, right? And those two don't necessarily always go hand in hand. Yeah.
So sometimes the middle ground might also work, right? For a stylized model, have theoretical results, and then have the more general study where you have a heuristic that sort of has some elements of that theory, but is something that can be applied, is interpretable.
That's what I'm trying. Either I compare against a neural net and beat that, or this side is have some theorem, like whatever weak bound, some bound, which is like not relevant.
Some theory that provides an insight into the problem, and then the heuristic sort of builds on top of that.
Yeah.
And
Thank you.
Wonderful. I would say, unless there's a last question, that we probably are ready for a break.
Actually, one announcement before we take the break, but go ahead. We can say thank you to the panelists anyway.
And then I wanted to thank the panelists.
Sorry.
I think there is one last question.
I'm sort of new into the data science field, and working on my master's degree as I speak. But I do have a background in supply chain management. And throughout all my classes and most of my readings, I am seeing blurbs saying that it really, really helps to have a wide expertise in a realm in which you are applying data science to. And I'm curious, since this conference is tailored towards supply chain management, did you come in to data science with supply chain management backgrounds, or did you find yourself applying your data science knowledge to new fields that you had really never ventured into before? And what was the effect of doing one versus the other?
Interesting question. Maybe we can quickly go through the four panelists to give their history.
Sure. Should I start with me?
Sure.
Okay. So I did an undergrad in CS, but I took math courses. Then I came to a PhD in OR. So my training is data science or operations researcher. And then I worked on supply chain problems, which motivated other optimization problems. And then it was sort of bouncing back and forth. Right? So it's not, and I work on other applications as well. So that's what happened with me.
Yeah, so I had a math background and had done some programming, and actually just by chance ended up working at a trucking company while I was in college and just for a short time after college. And that's honestly probably how I got the fellowship that I got into graduate school, and because I was working then for the Sloan Industry Trucking Project. Yeah, so I just sort of was in that. But then you kind of end up you also learn new skills, and then you go to new applications, after that. So at a certain point, it just sort of became kind of, the bouncing back and forth. That's a good way to put it, because that's what happened. Yeah.
Yeah, so I found myself in supply chain early on. Optimization, the machine learning came up. I sort of figured that out in terms of supply chain. I think it really helped. And what I saw is that a lot of people who were generically trained in machine learning couldn't understand the nuances that went on in supply chain. And likewise, I had a hard time understanding what the nuances were in marketing. So there, that context really helped sort of frame sort of how I thought about and how I see other people think about, how to apply these algorithms to solve the real problems that people have.
I think, honestly, it's completely irrelevant for you how we got into this, because most of us, at least, were educated at a time where there was not data science and there was no machine learning, so we transitioned into this. But maybe if you want, talk to this group over there. I mean, they're doing a supply chain. I think none of them was educated purely in supply chain. They're all mathematicians or people doing IS, and supply chain came later. They were data scientists, and supply chain came later. And I think, to me, this is the more natural way to go. Yeah. But that's my subjective opinion. Yeah. My background is supply chain, but that's because there was no data science at that time. Yeah.
I think at a broader point, there's a big fear in the supply chain community. I think that because when we went to school, it was like if you like data, we get into supply chain basically. And now if you like data, you can get into almost anything. And so I've kind of seen, if you're a supply chain company, I don't know how many practitioners we have out there, but it's actually harder to get talent that knows supply chain, because all this same talent that you would have had 10 years ago is now getting gobbled up by Google and Facebook and other places. So there is an issue for the supply chain community to worry about that a little bit.
Although this is again where the pandemic is going to have that benefit. The supply chain programs are exploding right now because people are hearing about it on the news so much, and then they'll see, oh, hey, there's a supply chain program at my university. I'm going to do that.
That's correct. Relevant.
Yeah, it must be relevant, right? I'll get a job. So yeah.
All right. Okay. Thank you very much, guys. We're going on a break, Larry.
We're going to do one introduction first, so just hang on for 1 second. Thank you, though. Okay, so I mentioned earlier that this is the third in a series of Tripods X workshops. These workshops are funded by an NSF grant that was earmarked for 4 Tripods X workshops, and the 4th we're happy to announce, and David's going to take it from here.
Yeah, so as slide shows.
Oh, sorry, wait. You need a mic here.
Oh, yeah. Podium. As the slide, yep, good. As the slide shows, that the proposed next workshop in the Tripods Plus X workshop series will be on ML for social good. It'll be held at Cornell University, high above scenic Cayuga's waters. The focus will be on applications in health and education and the methodological challenges associated with deploying machine learning in these environments. So the dates are tentative. In this world, everything is tentative, but we'll try to be sure, send out further announcements as we get some projection as we go through the new year and understand what the next semester is looking like, whether that's as viable as it might have looked a week ago. So if there are any questions, just ask me during the break.
Thanks, David. All right, so now we have a break, and we'll be back here in 15 minutes for the last talk for today.